Hello, today we're going to start up with a little bit of a review from yesterday. Hopefully you have your worksheet out. There's something I want to show you that talks about that's concerned with the last question of the worksheet. So let's look at when the degree of the numerator was less than the degree of the denominator. So that would be like 1. In number 2, the denominator is greater than the numerator. In 3, they're even. 4, numerator's bigger. 5, they're the same. 6 goes down there. 7, they're the same. 8 is down there. And 9 is there. Now hopefully, if you take a look at these answers, here goes to 0. This one goes to 0. So you could figure out that the general rule is if the degree of the denominator is larger than the degree of the numerator, that the limit, I shouldn't have to say equals 0, it's not very appropriate. We should say, or maybe I'll turn this into limit as x goes to infinity of this. That'll equal 0. So the limit as x goes to infinity of f of this f of x, that'll equal 0. Now here, the limits, this one was 4, 2, 1/3, and negative 3/8. And down here, this one would go to positive and negative infinity. This one would also go to positive and negative infinity. And this one would just go to infinity. So if the degree of the numerator is bigger than the degree of the denominator, it'll go to some sort of infinity. If it's just 1 degree higher, it'll be a line. So one side will go to infinity, the other side will go to negative infinity. In a parabola like this, if you divide these x fourth over x squared, it'd be some sort of a parabola. So it'll either be positive infinity or just negative infinity. Since this would be a positive x squared, it went to infinity on both sides. Now, where the degree of the numerator is equal to the degree of the denominator, we'll just look at this. 4x over x squared will be 4. 8x squared over 4x squared will be 2. If I multiplied this out, it would be x squared, so x squared over 3x squared would be 1/3. And here our largest degrees are going to be negative 3x over 8x, which we could simplify to 3, negative 3/8. So that's just a shortcut, so we don't have to do that whole process every time we want to figure out where our end behavior is. Now, one thing to keep in mind, I know you're brilliant squeeze students. However, some people forget these common fractions. 0 over 3 is going to be equal to 0. That means I have a box, I cut it into 3 equal sections, and I color exactly 0 of those boxes. None of them are colored. That's 0. This one is undefined. What that means is I have a box, and I cut it into 0 sections. Well, if I can't cut it into 0 sections, if I did that, there wouldn't be a box. And if I don't have a box, how can I color 3 of them? This doesn't make any sense with fractions. So anything over 0 will be undefined. All right. Now, if I'm in this situation, if A is positive, B is negative, and C is positive, it's any type of number. A plus B plus C, is this going to be positive or negative? Hopefully everybody's saying it depends. Depends what our positive and negative numbers are. This could be 5, -1, and 7. That would produce a positive number. However, if this turns to -19, now that makes a negative number. All right, now if this is 5, -1, and 7, this will have to be a negative answer. Even if I put -19 in here, it'll still be a negative answer, because a positive times a negative times a positive will always be a negative. Same with a positive times a negative divided by a positive, that will still be a negative answer. So it's nice when things are written as a product of factors, so that we can see whether things are going to be positive or negative. All right, so let's graph this equation. Now, my zeros are what makes this numerator 0, because zeros are something like 0 over 4. Um, so what would make this numerator 0? Hopefully you're saying negative 5. So negative 5, 0 is my 0 in this situation. So I'm going to actually sketch this as we move along. So I'm going to go to negative 5, 1, 2, 3, 4, 5, and negative 5, 0 is a 0 in this function. The y-intercept, that's when I plug 0 in for x, and I see the y. So if I plug in 0 for x, I get 0 plus 5, which is 5, over 0 minus 2, which is negative 2. So y is equal to negative 2.5. So if I plug in a 0 for x, my y is negative 2.5. Now I'm going to put that on the graph. And that's going to be my y-intercept. My equation of my vertical asymptotes, that's going to be where this function is undefined. It's undefined with this denominator 0, and that's going to be at x equals 2. So at x equals 2, I'm going to draw a horizontal line. So that's going to be my vertical, geez, that's y equals 2. That doesn't make sense. X equals 2 is over here. Let's try that again. Alright, now my end behavior, since these are my largest degrees, that would be 1 over 1. So y equals 1 is going to be my end behavior. So I can pull this horizontal one down again and put it right there. Alright, now we look at our sign chart. And on my sign chart, we want to put on zeros and vertical asymptotes, because those are the only way we can change from below the x-axis to above the x-axis. So my 0 is at negative 5. My vertical asymptote is at 2. Now we pick points to the left, in between, and to the right of these values. If I pick some value way off to the right, let's say 10. 10 plus 5 is positive, over 10 minus 2 is positive, so positive over positive will give us a positive result. Anything in between here, let's plug in 0, because we've already done that. If when we plugged in 0, we got a negative 2.5. So that means everything between negative 5 and 2 will produce a negative answer. Now everything to the right of negative, or to the left of negative 2, let's say negative 10. Negative 10 minus 5 will be negative over negative 10 minus 2, which will also be negative. So negative over negative will again be positive. Alright, so let's figure out how that works in this graph. So as I move way to the left, it's going to be positive, and it's going to go towards this line. So it's going to be positive, it's going to hit there, and then it's going to keep going, it's got to pass through this, and then go to my vertical asymptote, which I'll have it keep going down. Now just to the right of this vertical asymptote, it has to be positive, so it can't start here, it's got to start at the top. So it starts at the top, comes down, and then works its way out to my end behavior. So this is how we graph our rational functions. Alright, let's do this one. Our 0 is what makes this numerator. Actually, I want you to pause this and do as much as you can on your own, and then start it back up again when you feel like you're ready. Alright, the zeros are what makes the numerator 0, so that would be the point 3, 0. The y-intercept is if I plug in a 0 for x, so that would be negative 3 over negative 1 times 1, so that would be negative 3 over negative 1, which would be 3. So the y-intercept is at 0, 3. Funny, these things just change spots. That's not going to happen often. The equation for the vertical asymptotes, that's what makes this denominator 0. So x equals 1 will make this turn to 0, and x equals negative 1 will make this part turn to 0. My end behavior, this denominator, if I multiply it out, would be x squared plus something. Actually, x squared minus 1. And the numerator is x minus 3. So since the denominator has a larger degree than the numerator, the end behavior is just y equals 0. So now I will sketch my graph to the right here. We'll have 0 at 3, y-intercept at 0, 3. Vertical asymptote at positive 1. Try this again. At positive 1 and at negative 1. And now our end behavior is at y equals 0. So I have all these things on my graph. Now I just need to figure out how to graph it. So my sign chart, we put on our zeros. So 3 and 1 and negative 1. And now we graph it. If I pick some value to the right of 3, let's say 4, the numerator would be positive. That would be positive, positive, so everything would be positive. So we put in a positive. Between 1 and 3, let's pick a 2. 2 minus 3 would be negative, over 2 minus 1, which would be positive. 2 minus 1, which would be positive. A negative over positive would be a negative. Between negative 1 and 1, we've already plugged in 0, and we saw that that gives us a positive 3. So that will have to be a positive. And then to the left of negative 1, say negative 3. Negative 3 minus 3 would be a negative number, over negative 3 minus 1, that's a negative, over negative 3 minus or plus 1, which is another negative. So negative over negative times a negative, that would be a negative. Alright, so now let's figure out how we can draw this. If I start from the left, it's going to go towards the end behavior, so I can figure out the end behavior on the right and the left. It's going to go towards this. Now it says that this has to stay negative on the left-hand side, so I'm going to go down. It's not going to cross anything, so that once it hits the asymptote, it has to turn going down. It couldn't go up because it can't cross this axis, and because there's no 0 in here, and it says it stays down this whole time. Now between negative 1 and 1, it's positive. So it can either start down here or up here, but since it's positive, it has to start at the top. It's going to come through, hit there, and it has to keep being positive the whole time in between here. So that means it kind of does a parabola looking thing. It's not a parabola, but it's similar to a parabola. Now here, it can either start at the top or the bottom. Since this says it's negative, it's got to start at the bottom, come up. It's going to cross through at 3, but after 3, it's going to stay positive. But it's also got to go towards my end behavior. So it's going to come up and kind of curl back down towards my end behavior. All right, that is my function. Crazy looking function. All right, next one. Try this one on your own. See how far you get. All right, the 0 would just be 0. My y-intercept would be 0 over some other things, but that's just 0. Vertical asymptote would be at x equals negative 4 and x equals 3. My end behavior, since my denominator has a higher degree than my numerator, it'd just be y equals 0. So now let's do our sign chart. That's not what I was looking for. Alright. Now I like to sketch this out first, just to see what's going on. We have a 0 at 0, and that's also the y-intercept. We have a vertical asymptote at negative 4, and another one at 3. Now we have a sign chart, which looks like so. negative 4, we have 3, we have a 0 at 0, and now we need to see what else is in this function. Now from the graph it doesn't really show us where it could go. It can go in many different directions. I forgot to put my end behavior on here at 0. Let's move that up a little bit. Oops. So, to the left of 4, let's put in a number, left of negative 4, I should say. Let's put in like a negative 5. That would be a negative over a negative times a negative. So 3 negatives would give us a negative value. Let's just plug in like a negative 1. Negative 1 would give us a negative over a positive times a negative. So there's 2 negatives, so that would make it a positive. If I plug in a 1, that would be 5 over 4 over negative 3, so there's only 1 negative. That would make it a negative. To the right of 3, say 4. Positive, 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 so that would all be positive. When I start my graph, I know on the far left it's going to go towards that end behavior. On the far right, it's going to go towards this end behavior. Now let's fill in the rest. This first is a negative, so instead of going up, I'll go down. And it can't cross this vertical asymptote. Just to the right of that, it's going to be positive, so it has to start at the top, come down. It's got a 0 at 0, and then it turns negative, or it comes down like that. Now between 3, or after 3, it starts at the top. It's going to be positive the whole time, and then it's going to go towards that end behavior as it goes off to the right. So here's our graph. All right, let's try another one. We have 2 more left, and then we're done with this lesson. So hopefully you pause the video, go through this on your own. It has zeros at negative 1, a y-intercept at 1 over negative 3 times negative 4, so that's 1/12, so 0, 1/12. Oh, and this should be negative 1, 0 for 0. The equation of our vertical asymptote is going to be x equals 3, and x equals, it would be 4/3, because set this equal to 0. Our end behavior, if we multiplied these out, we don't have to multiply the whole thing out, but x times x, this would be x squared plus 2x plus 1. This one would be 3x squared plus some other business. And so when we divide it out, it would be y is equal to 1/3. So when I draw a sketch of this, again, I'm on the wrong line. Let's pull it over here. And if I graph the rest of this out, all right, the 0 is at negative 1. The y-intercept is at 1/12, so it's really close to 0. The vertical asymptote's at x equals 3 and x equals 4/3. So if I 1, 2, 3, we could draw another one at 4/3. All right, now we can draw our sign chart with our zeros, which is just negative 1, and our vertical asymptote at 4/3, and another one at 3. Now sometimes it helps to say that that's a 0, this is a vertical asymptote, this is a vertical asymptote. Now we know 0 lies in here, and it's a positive 1/12, so that's an easy part of our sign chart, so that's positive. To the left of negative 1, so if I put in negative 4, let's say, negative 4 plus 1 is negative 3, negative 3 squared is going to be positive. So positive over negative 4 minus 3, negative, negative 4 times 3 minus 4, that's also a negative, so negative times a negative is a positive. So over here is going to be positive, positive. Between 4/3 and 3 is the number 2, so that numerator is going to be positive. 2 minus 3 is negative. This would be 6 minus 4, which would be positive. So there's only one negative in this situation, so that's going to be negative. Now way off to the right, it's going to be positive over, say, if this 4 minus 3 is positive, that would be positive. So that's all positives there. So that's our sign chart, positive, positive, negative, positive. So if my end behavior is x equals, or y equals 1/3. So at 1/3, I'll draw this asymptote. And so off to the left, off to the right, it'll go towards that. Now it's going to stay positive the whole time. It's going to come down and hit at 1, and then come back up and be positive until it gets, or as it gets closer and closer to the vertical asymptote of 4/3. Now it's negative between these vertical asymptotes, so it's going to start low and then end low, curve around somewhere in there. Then just to the right of this 3, it's going to be positive, so it has to start at the top. Oops, that does not cross that vertical asymptote. It's going to start here, come down, and then get closer and closer to my end behavior. All right, we have one more. Try this one on your own and see how you do. Hopefully you've paused it, and now you're done with the problem, so we can just check it. The 0 would be at 0, 0, and there's another one at 3, 0. The y-intercept, if I put in 0, it's just going to be at 0, 0. The vertical asymptotes are going to be at x equals -6 and x equals 5. My end behavior, if I multiply this out, it would be 4x squared plus something, and the denominator would be x squared plus something. Since it's the common, it has the same degree, it'd be 4/1, which is y equals 4. So I'll go up 1, 2, 3, 4, draw my horizontal asymptote, and then at x equals -6, 1, 2, 3, 4, 5, 6, and x equals 5, 1, 2, 3, 4, 5. I'll draw these asymptotes. Alright, so now my end behavior, it goes towards this on the left and to the right. My sign chart has a 0, 3, -6, and 5. So -6, 0, 3, and 5. So two easy ones in this one. There's at 4, it's got to be positive to the left and to the right. So these two have to be positive. If that wasn't true, then we would have had our end behavior incorrect. So there's just 3 to fill out. If I have a -5, that would be negative, negative, positive, negative. So there's 3 negatives, so that would make that a negative. If I plug in a 1, that would be positive, negative, positive, negative. 2 negatives make it positive. If I plug in a 4, it would be positive, 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 negative. So now we have all of our signs. Everything to the left of -6 is going to be positive, so it's going to be positive. It's going to have to go up instead of going down because it stays positive the entire time. Just to the right of 6, it's going to start being negative, and then oh, I don't have my zeros in here. 0 and 3. It's going to come up, cross through my 0 at 0, cross back through at 3, and now it's going to go down towards this asymptote. Then to the right of 5, it's going to be positive the whole time, so it's start at the top, curve back around, and this should never go back on itself. That was kind of bad drawing. All right, hopefully that worked out for you. So now you can start the homework. Good luck.